Thanks for having me again. So no pressure if I want to be back in South America next year, so I better deliver today. Welcome and hello, Australia. It's a wonderful country. And the first time here, I very much enjoy it. I tried to focus on the aspect of development with containers in a distributed setup. So quick show of hands, who of you is a developer, mainly doing development? Okay, who is doing mainly operations? Okay, 2 hands, you're very busy. DevOps, do we have real DevOps here? Oh yeah, of course, you again. Okay, cool. So let's have a quick look at the underlying motivation. Why are we, why I'm talking about that? So how we, and I admit I have been doing that as well. How we used to do things. So we have development side and operations side. So you're adding some features, right? Or squashing some bugs. You do some testing, some unit testing, hopefully. You push the repo, and then you throw it over the fence, right? Maybe yourself or a colleague SSHs into the server, pulls from the repo, maybe does some smoke testing, rolls out a new version, and gets paid at 3 a.m. And then grabs the developer and says, "Argh." So no more throwing over the fence, right? We have communities. We are cool, right? We can do that. A few challenges that we are facing. You haven't read that book? Oh, you should totally read that book. That's one of my favorites. So these days, nowadays, if you think about it, we have this a bit entitled, right, with this kind of 24/7 available mentality, right? Damn it, I cannot Instagram that picture that shows me at 3 o'clock in the morning in a very sorry state. You expect to everything, be it banking, be it social media, whatever, everything should be up and available all the time. You need to ship faster than your competition, because as you know, as Mark and Reason already said quite a while ago, I think 2011, software is eating the world, and if you're not shipping faster than your competition, you're out. You did notice I didn't say you're fired. DevOps, all the DevOps things, right, in the last couple of years became mainstream. And we do have a DevOps, at least one, or is it a DevOps here? Obviously, containers happened, and we're using and benefiting from containers. Increasingly, we're operating our stuff on or in clusters, if you like it or notice it or not. And then obviously, the cloud. So all of these things, on the one hand, they're great. On the other hand, from the traditional way of things, how we used to do things, they introduce a couple of interesting challenges. So how that whole thing started was end of last year. I blogged about this, how we develop in and with distributed systems, and turns out this is very applicable to containerized environments that typically run in a cluster of machines. And based on that blog post, I gave a talk on that and another one. And over time, I learned, having conversations with people, I learned a few things, and I thought, now it's probably a good time, since I'm first time here, I'm going to give a slightly updated and hopefully interesting talk on that topic. So the basic question is, in a containerized environment, take Kubernetes or whatever, you as a developer, you're still focusing on writing code, but then there are other artifacts we're going to have a look at in a moment. And then there's the cluster where you execute stuff. So if we look at the development build artifacts here, then obviously you're still dealing with the source artifacts, right? If you're a Java coder, you have some Java files and config files and whatnot. Now, the containerization adds this packaging layer. So someone is writing a Docker file or ACI or OCI, whatever. And last but not least, you've got the runtime environment. So you should be using Helm charts, or you're manually writing a Kubernetes replication controller, or a Docker compose file. Whatever it is, saying, okay, this container image with these parameters, with these resource limitations in this environment, with these labels or whatever, go off and run that for me. And if you think about it, on a conceptual level, you can separate between, there's something running locally on my laptop here, and there is something remote, something that I need to access. I need to be online to access it. And in one setup, the pure offline mode, as I call it, you would have the development and the cluster both on your machine. In proxied mode, you would have the cluster remote, but you would have a proxy, you would have parts of the system, parts of the container orchestration proxied onto your machine. So you would have, it looks like it is locally available, but really it's running in a cluster. Live, for lack of better terms, so if you have a better label for that, I'm all open, all ear. The cluster and development environment are essentially separated, and you're using an API or kubectl or whatever to communicate. And then you have the pure online case, where both the cluster and the development environment is, in fact, in the cloud. And as you can imagine, each of these modes, and this is not black and white, right? It's not just pure offline or pure online, have certain advantages and disadvantages. And if you can choose, if you are in a position to choose, then hopefully this talk gives you a bit of a background to argue with your admin or your boss. In reality, it's really a bit more complicated because you have your editors, right? Your development environment, whatever. You've got your code somewhere, right? If you have deep pockets, you might be able to have GitHub Enterprise or GitLab, whatever, on premises, or typically use GitHub online. You've got your build system that needs to run somewhere, right? Again, it could be on your machine or could be in the cloud. You've got your container registry. All these build artifacts, all these container images need to be somewhere in order so I can pull them in from the last bit here, the container orchestration system. And for each of these components that you naturally need to use in order to end-to-end deploy a new version of your piece of code, could be local or could be remote. Okay, let's have a look at each of the modes, and then the last 5 to 10 minutes, I'm gonna do a live demo, so fingers crossed. Pure offline mode, essentially, more or less, you don't need to maintain a cluster. We're gonna have a look at the examples in a moment. Typically, it's like 1 VM or 2 VMs or whatever, everything packaged, you just install it locally, and that's fine. And that also means no cost, right? You're not paying AWS for a few VMs that are just sitting there because you go to bed. Obviously, the offline, everything on your laptop means that you can rather iterate fast, so you can very quickly push out a new image and deploy a new version of your service or your application. The scale is obviously limited. Typically, at least these machines have 16 gigs, so you can guess how much you can do there. And it's not really a distributed system, and that means that for certain failure modes, you can't really replicate them or try it out in such a setup in a pure offline mode. And it is also the case that sometimes not all of the functionality is available. There are certain compromises that people who put that together made in order to make it run, but not always everything is available. And examples there are the well-known Minikube, Minishift, the OpenShift version derived from Minikube, Docker Swarm on Linux, Windows, and macOS, DCOS Vagrant, and so on. That's specifically for the container orchestration part, which is, I guess, obvious. In proxied mode, this is almost the real thing. The better the proxy, the more you actually get exposed to your local system, and it allows for pretty rapid development cycles. It's almost pretty much as good as the pure offline. You still have to maintain a cluster, so someone, either yourself or your infra team has to give you access to a cluster, which means there are costs. And it's limited offline development. So you might be able to do certain things locally, but if you, for example, have Kafka running in a Kubernetes cluster and you need to put something into Kafka, then if you don't have access to a cluster, then you can't test that part. Examples in that space are kubectl proxy, telepresence, which I suggest that you have a look at if you're on Kubernetes, DCS Tunnel, all of them in a certain variety do this kind of proxying for you. And this is my default. I typically do proxy mode. And last but not least, or one more, live mode. This is the real thing. This is the distributed system, the cluster. Obviously, there are the costs involved, same as with the previous one. Very limited offline development. You really have to go, and we will actually see that in the demo, you really have to go all the way, building the image, deploying a new version, and so on, just to see the change of one line in the code, which means slow development cycles. Examples here, OpenShift, which is a Kubernetes distribution that packages some other things like container registry and the build process and so on. You can use vanilla Kubernetes with Jenkins, Tectonic with TeamCity, Marathon with Bamboo, Docker Data Center with Travis, or whatnot. So all of these combinations there essentially have this. That's usually when I talk with people, initially that's the default for many people that start with that new way of developing, that they see that, and that's how you do things. Okay, pure online mode. This might not be something you have already tried out. If not, then you should. It is a real thing. It is a real cluster running out there. Usually, or in certain cases, it's pretty cheap. Could even be free. I'm going to show you the examples in a moment. It scales well, and the biggest disadvantage is obviously there is no offline development. If you're not online, then you can't do anything. And some of the offerings have a limited lifetime, so you might only have your cluster for a day or a month or whatever. And typically, you also have very limited control over the environment, so you can't really be picky. You just need to use whatever is there. Examples include OpenShift.io, which integrates Eclipse, GA, and Fabricate. Katacoda, we're using it in OpenShift as well. Has many other environments there where you can try out stuff, and there the cluster is, well, whatever. I don't know if there's a time limitation, but it's essentially while you're doing your exercise, the cluster is available. Google Cloud Shell plus GCR and the container engine, pretty nice environment, and coding is another example of that category. And again, I'm not advocating you should always do X. What I want you to take away from this talk is being aware of the different modes, and if you can, choose wisely, depending on your preferences or needs. A bit of a warning, there are things that you should think about, and that is one that I had to figure out the hard way, the reverse access path. So just because I can talk locally from my machine to Kafka doesn't necessarily mean that my local running service is available from within the cluster. Right? So if you have 5 microservices, the microservice number 3 might not be able to talk with yours, right? Depending on the mode and setup. What about logs? Can I get to them? What about debugging? Can be tricky. Load testing in certain areas, and tracing or distributed tracing. So all of these things, if one of them stands out, or you said, oh, I really need these reverse access paths from the local point of view, then yeah, for example, pure offline would be out of question. Okay, great. I went through the slides very fast, which is great, which means I have a lot of time for the demo. All right, actually see that? Perfect. Okay. Now, that okay, the last row? Can you see that? Yeah, okay. So where do we start? We start at the beginning. That's a good place. Now, I've got this little super interesting app server, whatever, written in Python here. It's up on GitHub. So I'm using, obviously, not a pure offline environment. I could have deployed GitLab in my OpenShift cluster I'm using here, but yeah, I happen to use GitHub now. And it doesn't really do much, right? It's like really, it just has 2 endpoints there. Let me show you that code. And I think you can agree that this is not the most complicated or greatest service written ever, but it does its job. So, you hit two endpoints, either info or health, and then you get a few things back, and that's pretty much it, right? And you can run it locally. So if we go to this one here and start the service, and then just query it, host 9876 info, then I should get back, yeah, cool. I've been invoked from localhost, and it's running on localhost, and it's in version 0.3. Right? So that would be somewhere in the development cycle that is your current version. Not sure if I can raise VC money with that, but there you go. Okay, so what we want to do is, in the first step, let's see if we get to the second step, I've got a cluster up there, and that is OpenShift Online. I think it's still limited to a month, correct me if I'm wrong, and there are some quotas in place and so on, but you've got a fully working Kubernetes cluster for free where you can deploy stuff. So that's what I did. I'm using that. And what we're going to do now is initially just setting it up, so creating a new project for it. Project essentially is the OpenShift alias for namespace. We're going to create that app, and as I said, OpenShift has this built-in build process where you essentially say here, I don't know if you can see it. Tell me in the last row if you can't see it. So with that, I essentially say, hey, use Python 2.7 container image, and then here's the code, right? Go off and grab the code. I can let OpenShift just guess. There are certain conventions there. If it finds a requirements file, it guesses, oh yeah, that's Python. But I want to pin it down to 2.7, so that's why I explicitly tell OpenShift use this. And then a few environment variables that I had to set here because I'm stupid and I don't know the Python convention, so obviously I had to use cwc.py rather than main or app or whatever. And the port, because that's just a OSO limitation, because it apparently doesn't let me change the port there, so I need to force it to a certain port. Then I'm building it, and then I'm deploying it, and then we'll see it live. So hopefully in 2, 3, 4 minutes, depending on how fast the network is, we will see that live, right? Then we've set it up, that's the initial deployment, and from then on we can change stuff. So let's get back to this one here, that looks good. So first step, creating the project, the workspace. Now, fingers crossed that at some point in time, if I reload that here, I see the project. Perfect. Now, that is the kind of environment in which I'm going to deploy my little app here. And as I said, project is just a alias for namespace. So the underlying, if I here say kubectl, or kubectl is just a symlink to OC on my system, get ns, you would expect to find that. Network is a little bit, so can you stop downloading something from Maven or whatever? Stop streaming Netflix. Hello? Okay. Yeah, live demo, whatever. Next, I'm gonna deploy the app, so pointing at the repo where it is and saying, hey, create a new app with using this Python 2.7 base image. And what it does essentially, bit like the Helm chart that we saw early on from Michelle, first it builds the stuff, right? So you see a build bot there that goes off and just builds the stuff. And at some point in time, the build is done, and then we'll see the deployment. So let's check the logs. Boom. We should hopefully see that the build process, and that is the kind of critical area where my quota, I'm hitting the quota there already, so no build. Okay, it takes a bit. It takes a few moments until the build pod is spun up, or I have a resource issue. We will see. Do we see anything here? Okay, not yet. Any questions in between? No? Okay, cool. We still have a few minutes, yeah? Cool. Yeah, welcome to a live demo. Yes, that looks good. Come on, show us some logs. So I'm just tailing the build log. So essentially, the build bot also runs in Kubernetes. And now you see, okay, it pulled it, using the internal registry, building the stuff, many things that I've done wrong there. I don't know actually what I've done wrong there, but doesn't matter. That's doesn't influence the application. And finally, it pushes the image to the internal registry that runs here. So hopefully, sorry? Oh, yeah, that's fine. Thank you very much. That's fine. You know, so I can still blame the network or whatever. So. Okay, push successful, so we should actually see something here now. So we have a deployment here that has been created with one pod running, right? Getting there. Okay, that's cool. And yeah, we can check the status. It's just, you know, where are we currently will tell me hopefully that whenever it comes back, that the project, the application exists and is available there at some point in time. Okay. Maybe we do try that. Do I need to configure anything, or is it just will work? Okay. Okay, fine, I got the status. And now I don't have anyone else to blame but myself if something doesn't work, right? Okay. So I'm looking at the so-called deployment configuration, which is a kind of abstraction to a deployment that we have in OpenShift, many other things that are on top, that are a bit more abstracted away, but it might be on the other side. I can't really blame. Okay, so it's running out there. That's great. And last but not least, so it's running in the cluster, but it's not yet available from the outside world. Now I'm exposing it. Now I'm saying, hey, you know, I really want to make that service available to the outside world. And we have a concept called routes, which is somehow comparable to or more or less the same functionality as ingress. And now I should hopefully see the route there. And yeah, so if I go here and say info, not yet, but soon. Yeah, right, success. So I'm running on this machine, version 0.3, and the request came from my local IP. Okay, cool, perfect. So this was, that's an alternative way if I want to do it from the CLI, just grabbing using the routes object, grabbing the domain name, the FQDN from it, and then I can just hit it with curl, or I usually use HTTP. So I can do the same that I did in the browser in the previous step from the command line. So great. So now what we've done is we've developed something locally, and a remote cluster is running the current version. And now get a call from the boss, says, Michael, you've got until tomorrow to roll out a new version. So I head back to here and go like, after like many hours of coding, I'm on version 4. All right, so what are we gonna do? Some people laugh at me because I'm using Tower. I don't care, I like it, and I paid for it. So, dear boss, successfully, no. Just, bumps the version, whatever. To version, whatever it was, 0.4, I believe, right? Committing that, now I have it locally. And obviously I want to push it. Otherwise, it won't work. Now that I have updated it, I could, again, I was too lazy to actually do it. I would have needed to do a few other things. I could have created a GitHub webhook and just do it automatically. Whenever it sees a push, it would kick off that build process. As I said, since I'm lazy, just doing a manual, kicking off the build manually. So with that, again, it says, hey, I know that there's a new version of my software, of my Python app server on GitHub, so start a new build. And after a minute, I timed it, I did it a couple of times, we will actually see something. So let's go back here. We should see a new build and a new deployment. And after maybe a minute, roughly, I'll hopefully have a new version there. But you actually don't really see it because I changed it here, but not here. Good thing that, oh no, I did. That's fine, okay. smart enough to change that. Okay, still running, still building, you know. And if you think about that, every time, now, you know, you might not do a push or whatever after a single change in your code base, obviously, I guess. But maybe, you know, 2 or 3 or 4 times a day or whatever your policy or your team's policy is, you're gonna do that, and you're gonna need to test it out with other services in a cluster or whatever. And every time you do that, you have to wait exactly as long as I do here, right? And that sucks. That's not really something you want to do. Let's see, is the new version there, complete? Yeah, I know. I would pay you, but I can't yet. Okay. Of course, info. And version 3, really? Oh. Is that a quota issue? Let's see if the build worked. Complete, that's good. Deployments, that's all good. This is a bit strange, why I still see version 03. Let's see if that's a caching issue. Nope, can't blame the cache. So the second build, it's still running. I thought it's completed. It's still running, that's why. Okay, so I have to wait until the build is done. Sorry, the deployment. Now we are in the deployment. So it's doing another round of deployments, and now, hopefully, as you know, standard or default in Kubernetes is rolling upgrades. So now I hopefully see version 0.4. No, still not. What has gone wrong? Is there anything I forgot? No. That's pretty much it, right? Let's be lazy and just do that. So I'm just constantly, like every 5 seconds, checking. Okay, still not available. This is really strange. I have no idea what I did wrong. Maybe there's a quota issue. That is a bit, no, I'm fine here. No, looks good. Still not there. It looks like all is good, but I probably need to drill down to see what hasn't worked out. Yeah, running, that's fine. And it says version 0.4. So apparently the new pod is running, that's fine. And probably I was not, finally, okay. Yeah, thank you. All right, so the main challenge, as you can see, besides me being a tool, not knowing how to use a laptop, is that this cycle, right, really is that sucks, right? If you have to wait for 5 minutes, whatever, until you see a new version out there that can be tested with others or whatever, that just sucks. So you don't want to do that. And now I don't know how many more minutes I've got. Have I got 5 minutes? No, probably not. Yes, 5 minutes? Okay, but without. Okay, let's quickly do it. Let's, you know, if you have questions, feel free. I can, you know, multitask. All right, let's switch over to the local cluster. So I've Minishift running here. It's a local, like Minikube virtual machine that has everything that you need locally. And let's see if that improves things. I need to switch clusters. So please look away, that's my token. And so with that, I'm essentially switching my OC or kubectl to the local, to the Minishift cluster. Yeah, now I'm doing the same steps as with the other, right? Creating the project, boom, and here's already one place where you could optimize things. So rather than having that on GitHub, I could run GitLab. I could have installed GitLab on that Minishift cluster here, and would have been a speed up here. Okay, again, let's tail the logs. Okay, that already looks a bit faster than the other. Yeah, that's fine. How are we doing? Is it running? Yes, fine. Let's expose it. Okay, no pressure, exposed, fine. Where is it? There, fine, okay. Let's grab it. Let's use HTTP. Okay, hopefully, yay, version 4, great. Now, another change, another call. Yes, sir, I'm gonna up it to 5, okay. Gonna push it, yes, push it. Baby, yes. Who remembers salt and pepper? Yay. Come on. Commit, push, off you go. And almost there, almost there. Trigger the build and hopefully get a new version very soon. Start it, and then we just go, well, let's tail the logs, the build logs, to see. Wow, is that fast? Huh? So that's already improved a bit, right? So I guess you would agree that even if you take away my goofiness early on, that this is slightly better. This is a bit better version 5, right? It's like maybe a third of the time it took me previously. So again, and these are just two, if you have the spectrum from pure offline to pure online, 2 data points in the spectrum. So yeah. All I can say is I encourage you to think about it, what you prefer, where your preferences are, and I guess faster is indeed better. Thank you very much.
Thank you, Michael.